Hello everyone, so welcome to our video lesson. My name is Waziri Omari and today we'll be solving one of the challenging problems from the Randall book. It is question number 76. So the question reads as, two 3.0 gram point charges on 1.0 meter long threads repel each other after being equally charged. So what is the value of charge Q? So you can see this is the diagram. As you can see from the diagram, you are being given 2 point charges and their magnitude is Q, and they are placed on a thread like this. So this is the thread for the first charge and this is the thread for the second charge, and the thread is equal to 1 meter long, so L is 1 meter, and the mass of each charge is 3.0 gram, which is equal to 3.0 times 10 power negative 3 kilogram. So after being charged to a charge Q, they are repelling one another. So the question wants us to find the value of charge Q. So for example, here you can consider maybe this charge. What is happening in this charge is the same as what is happening in the other charge. So we can just consider this charge. So we are told that this charge has a mass of 3 gram. It means it has also a weight. So let's say its weight is equal to mg, like this. And also we are told that this charge is being placed on a thread. So as far as there is a thread, so it means there is a tension. So let's say there's a tension T. So T stands for tension, yeah? So there's tension T. Tension. There's tension T. But also, since these charges have the same sign, it means they repel each other. So the force of this charge on this charge, it will be away. So this is the electrostatic force which will be acting in this direction. Let's call this Fe. So Fe, it stands for electrostatic force. Electrostatic force. Yeah, so we are required to find the value of magnitude Q. So first of all, we can resolve the tension, the tension force into its component, vertical and horizontal component. So it will have this vertical component of tension as well as this horizontal component of a tension. So this is angle theta, which is 20. This angle is the same as this angle, so this angle will also be angle theta. So for this component, it will be T cosine of angle theta, and this one will be T sine of angle theta. So at equilibrium, since the charge is not moving, so it means sum of the net force, it will be equal to 0. So if you consider horizontal forces, so let's say for horizontal forces, sum of horizontal forces will be equal to 0. And you can see you have only 2 horizontal forces. You have electrostatic force Fe, and you also have tension, the horizontal component of tension, which is T sine theta. So we know for horizontal forces, their sum will be equal to 0. Why? Because the charge is at equilibrium. So you can say T sine theta. This is positive because it acts in the positive x direction. So plus electrostatic force, we will say it is minus Fe. It is minus because it acts in the negative x direction. So their sum will be equal to 0. So from here we can say that T sine of angle theta, it will be equal to, so this one, if it comes to the other side, it is equal to Fe. We can call this equation 1. But also can do the same for vertical forces. So for vertical forces, the sum of vertical forces at equilibrium, the sum of vertical forces will be equal to 0. So you can look here also, you have only 2 vertical forces. We have the vertical component of the tension, which is T cosine theta, and also mg. So you can write the sum of vertical forces, which is T cosine angle theta. This is positive because it acts in the positive y direction, plus the other one, it is mg, but we write it as minus mg because it acts in the negative y direction. It will be equal to 0. So here you can see T cosine of angle theta is equal to mg. You can call this equation 2. So we have t, which we don't know. So in order to eliminate t, we can take equation 1. We can take equation 1 divided by equation 2. So what happens when we take equation 1 divided by equation 2? It will be like this. So it will be t sine of angle theta divided by t cosine of angle theta, is equal to electrostatic force Fe divided by weight mg. So from here you can see t and t will cancel, and we also know that sine of angle theta over cos is equal to tan. So tan of angle theta, it will be equal to electrostatic force Fe over weight, and from here we can say that electrostatic force Fe is equal to mg tan of angle theta. But we also know that from Coulomb's law, of electrostatic, from Coulomb's law of electrostatic, which says that if you have two charges, electrostatics, which says that if you have two charges, the force between two charges, which is Fe, will be equal to electrostatic constant K, the product of their charges. But because the charges are the same, we know that this is Q and this is Q, we can just write that K times Q square, so that Q1 times Q2 will just be Q square over R square. So this is electrostatic force. But we also know that electrostatic force is equal to mg tan theta. So you can say that this Q square over R square is equal to mg tan of angle theta. All right. So from here, if we want to find the value of Q, so Q square will be equal to mg. Then we have R square. We can multiply it there. Mg R square tan of angle theta. This all divided by electrostatic constant K. So from here, this is Q square. So if you want to get Q, so Q will be equal to mg R square tan of angle theta divided by K, but square root, right? So from here, just mathematics, you can take this R out. So it will be R square root of mg tan of angle theta divided by K. So we know the value of m, which is 3, g is constant, theta we know the value, K we know, but for R I don't know the value of R, and R is this distance from the first charge all the way to the second charge. So how to find it? You can consider this angle theta. We know the value of L, which is 1, right? So we can call this value maybe y, the value from the first charge all the way to the middle. So by using the sine relation, you can say that sine of angle theta, because that triangle is like this. So we have this one, which is L, and this one, which is y, and this one, which is angle theta. So sine of angle theta, it will be equal to opposite. The opposite is y over hypotenuse, which is L. So from here we can see that the value of y is equal to L sine of angle theta. But R, the value of R is from here to here. So this is y, this is also y. So R is equal to y plus y, or is equal to 2y. So R is equal to 2y, but y is that one. So R is equal to 2L sine of angle theta. So instead of R, I can write this value. So from here you can see that the value of Q will be equal to R, which is 2L sine of angle theta, multiplied by square root of mg tan of angle theta divided by K. So from here we know the value of each sine there. So it will be equal to 2 times L. L is 1.0 meter, sine of theta, which is 20 degrees, then square root of m. M is 3 times 10 power negative 3 kilogram, then times g, which is 9.81 Newton per kilogram, then times tan of theta, which is tan of 20 degree, divided by the value of K is 9 times 10 power 9. So if we do this and we put in the calculator, hopefully the value of Q will be equal to 0.75 microcoulomb. So this is the final answer of our question. So you can see, first of all, we find the components of tension. Then we know that at equilibrium, the acceleration will be equal to 0, so the sum of net forces will be equal to 0. So we consider the horizontal component first, and we came up with this equation. Then we considered the vertical components later, and we came up with this equation. And we took equation 1 divided by equation 2 for the purpose of eliminating the T, because we don't have the value of T. We don't know the tension. So that's why we took equation 1 divided by equation 2, so the T will cancel, and we will remain with this equation. This equation gives us the value of electrostatic force between the charges, and we compared it with the Coulomb's law of electrostatics, which said that F is equals to KQ square over R square. So after comparing, we came up with this equation, and from here we made Q the subject, because the equation wants us to find the value of Q. So this is the equation which we came up, but from here we knew that we didn't have the value of R. For example, here you know the value of mass M is 3, theta you know, K you know, but R we don't know. So from here we used the sine relation of a triangle, and we came up with the value of R, and we put it there, and we substitute the values, and we get the value of the charge Q. So that's how we solve the equation, and thank you so much. In case of any misunderstanding, you can try to contact me later. Thank you.